Today we're going to be looking at describing a graph. There are many things that you need to know when describing a graph. Here is the list. Please take a second to pause this video so that you can write down this list. You'll also have this list included in all the assignments we do so that way you won't miss any pieces. But you need to know how to include all of these in your graph description. Let's look at each of these. First one is the shape. Again, earlier today we just talked about the different types of graphs: linear, quadratic, cubic, exponential, all of those types. You can use those as your shape, or you can actually just tell me the end shape of the graph. This is a line or it is linear. This is a U shape or it is quadratic. This is a V shape or it is absolute value. Either of those will be accepted. Next, we have line of symmetry. A line of symmetry is a line that divides the shape in half identically, to where if you were almost to fold the paper over, then it would make an equal shape on both sides. We write the line as x equals the number or y equals the number. If it is a vertical line, it will be x equals, such as this top one, x equals 3. If it is a horizontal line, it will look like this one, which is y equals -4. There are also some that don't have one. There is no line here that I could draw that would make both of these shapes match up. So therefore, this would be no line of symmetry. This one we can draw a line right here, which means it would be x equals 0 because it is a vertical line, so it would be x equals, and then because it goes through that point, 0 right here. Our next thing is going to be whether it faces up or down, or opens up or down. So keep in mind, this has to be almost one of those U shapes or those V shapes. It has to open up like this, or it has to open down like this. The next one is asymptotes. There are only certain graphs that deal with asymptotes. We have our rational graph here. We have an exponential graph, or one of our trigonometry graphs. Those are the only ones that have asymptotes. So linear, quadratic, cubic, square root, absolute value, those don't have asymptotes and will never have asymptotes. Again, rationals, exponentials, and trig functions are the main ones that have asymptotes. Those asymptotes are written as a straight line. So again, x equals -2, or y equals 1, or x equals 1. Our next thing is increasing or decreasing. So most shapes, you can look at it and see, is it increasing or is it decreasing? Again, there's some where you can just write increasing or decreasing. There's some where you need to tell when it's increasing, when it's decreasing. If it's doing it at multiple points, you need to have two things. Notice this graph right here is continually increasing, so it's just increasing. Notice this one, it decreases until it hits 3, and then it turns and starts increasing. So notice we're saying that it's decreasing until it hits 3, and then increasing from 3 on. You can write these out if you don't remember the notations. Just write it out. It's increasing on the left side until it hits 3, and then it's increasing on the right side through all the positive numbers. Notice here there's multiple steps. It's decreasing from here to here. It's also decreasing from here to here. So you have 2 spots where it's decreasing. And then that means you also have 2 spots where it's increasing. Our next thing is x and y intercepts. An x-intercept is where it's going to cross the x-axis. So where is it hitting the x value? So here's my x. It's only hitting in this one spot. Here's my x. It is hitting in 2 different spots. Here's my x. It's not hitting it at all. Here's my x. It's hitting it at 2 separate spots. That last line was a little off. So notice each of these is 1 point, 2 points, or none. My y-intercepts, on the other hand, are where it's hitting this y value. So again, if I draw my y line, it hits it at 1 spot, 0, -5. If I draw my y line, it hits it at 1 spot. All of these are hitting it at 1 spot. Notice if I were to have maybe like a curve like this, it would hit it in 2 separate spots. And then again, there could be a point where I have a graph that looks like this, and it doesn't hit it at all. So those are x and y intercepts. Then we have domain and range. Domain and range, domain is all of your x values that are possible. Range are all of your y values that are possible. So when we see arrows, that means that the graph's going to keep going at some point. So notice in this one, my domain, all of the x values are possible because of these arrows. It also means going up and down, all of my y values are possible. So for my domain and range here, it's really all numbers. I can write it like this, where it's -infinity through +infinity. I can also write all real numbers. Then you have these certain graphs where there's a starting point and then it goes up, or there's a starting point and a stopping point. These are your x and y values of your starting point and your ending point. So if I'm starting here and I can go all the way over here, then that means I'm starting at -2.5 and I can go all the way over to +3, and I can use any of those numbers. I can start down here at -10 and I can go all the way up to a +16, and those are my y values. Notice here, I can start at 0 and go up, so it's 0 through infinity, but also I can start at 0 and go to the right, which is all my positive numbers as well. So that's how we're going to state our domain and our range, is all of my x values and all of my y values. Endpoints. We're going to talk about whether we have an endpoint or not. An endpoint just means a stoppage of the graph. So if I have an arrow, there is no endpoint on that side of the graph. So if both sides have an arrow, such as a straight line, we have no endpoints here. Whereas this one, we have 2 endpoints. We have this point right here, which is going to be -212. So -2.5 and then 12 is one endpoint. This is a comma. My other endpoint is down here. It looks to be at -10 and, or sorry, 3 -10. I put my -10 first. We'll put 3 and then comma -10 right here. 3, -10. Notice on this one, there's only one endpoint, and that one endpoint is 0, 3. So stating whether you have an endpoint or not. Your next one is maximum or minimum values. Is there a maximum, a highest point of the graph, or a lowest point of the graph? Again, if you have arrows, that negates your highest or your lowest value depending on where the arrow is. So here we have arrows on both sides, which means there's no minimum, no maximum. It's going to keep going in both directions. Here, we have a minimum value. The lowest point on this graph is at -4, which means we cannot go any lower than that. So that is our minimum value. Here, there's no arrows. If there was no arrows, then we would have a minimum and maximum value, but we're assuming that there are arrows here, which means, again, it's going to keep going up and it's going to keep going down, which means there is no minimum or maximum value. Here, our minimum value, our lowest value is -10. Our highest value is 16. Our next thing is going to be continuous or discrete. Simplest way to determine this is, does it have just points, or are those points connected to make a line? If I only have a sporadic amount of points, that is a discrete graph. If I have a continuous line, so I have connected those dots to make it into a line, it is continuous. Our next thing, or actually our last thing, is going to be whether something is or is not a function. We shouldn't have to spend a bunch of time on this because, again, your first video talked about this. But again, think about that vertical line test. Can I draw a vertical line and it only hit 1 point? If I can, then yes, that is a function. Can draw a vertical line, only hits 1 point, function. I can draw a vertical line, it hits every single point on this graph, not a function. Here, if I draw this vertical line, it hits 2 spots, not a function. Yes, no, no. That is a quick synopsis of what is and isn't a function and how to determine what, or how to describe a graph.